In this lesson, we will practice finding the volume, area, radius, and/or diameter of various 3D shapes. We will practice using formulas, exponents, and roots, as well as other skills we have learned so far this year to find the volume or missing variable.
That was sick.
That was. Thank you. Recall.
It's like really boring.
Oh, sorry. Let me try this again. Recall that the formula V
Sal, just stop, please.
equals BH helps you find the volume.
We can use the formula.
I'm fluctuating my voice though, right? We can use the formula
Talk really high pitched.
A equals pi r squared.
Well, that really just
Find
answers
B.
everything.
Alright, use the picture below to describe how to find the volume of a cylinder. Be sure to describe each part of the formula and how it relates to pi r squared h. A cylinder is a solid obtained by taking a circle in a plane. I don't know why they said that, but called the base. So the circle is the base of the cylinder, and then we draw it out in a direction perpendicular to the base. That's very technical. All they're really saying is that you got to draw a circle, but in kind of like a 3D dimension, and then you draw it down like these, and then you draw another circle there at the bottom. Bam. Now, if it was circle that it circled, then it would become a sphere, which we're not so concerned with right now. But we can see that since this is a circle that's three-dimensional, this would be the radius up and down, and then the height would be these. So as it turns out, if we look at just one layer of this, then the height is how many layers there are. So really all we're doing is finding the area, which is also the volume of one layer, and then multiplying it by the number of layers. Alright, so that is the formula for finding the volume of a cylinder. That says area. I said volume, I meant. Volume is pi r squared h. And as it turns out, your calculator has a pi button. So that's all we're going to be using for this. If it does not have a pi button, then you should be using 3.1415. But let's use the pi button. Alright, now it gave us some problems, and we will use this to find the volume of these two cylinders. Alright, now it may again help to draw a model of these, and since we like drawing anyways, that's pretty nice. You don't need to use thick and thin lines, but right, some of you guys would be like, I'm going to shade it, and then it looks pretty. No, we're not going to do that. All we need to do is see that the radius right here is 21 millimeters, and then the height is 19 millimeters. So to find the volume, which is pi times the radius squared times the height, we're just going to replace the values that we know. The radius is 21, and the height is 19.
Can we just round up for all of these?
So I can type this in exactly as I see it. Alright, now this is a large number. I'm just going to round it to the tenths. My volume is 26,323.4. But we need to label this in millimeters cubed.
Hi.
Alright, cylinder with a diameter 8.8 centimeters and the height of 9. So the volume of the cylinder is always going to be pi times the radius squared times the height. Now this one, we do have the height, which is at 9 centimeters, right here. So we'll replace the height with the 9 centimeters. But the radius is not given to us immediately. It gave us the diameter, which is twice the radius. So we've got to take, the radius would be half of the diameter. So yes, the radius is 4.4.
You guys are also smart. I know, Megan. I know how.
Ooh, got him.
Oh yeah, very good. So I just plugged it all in, and I got 547.4.
Centimeters cubed.
Very good, centimeters cubed. That is the volume. So that was finding the volume if the volume was the missing measurement. But now, either the diameter or the height or the radius will be missing on of these. All right, the volume of this is 117.1 cubic foot. And the height is 15 foot. But what we need is the diameter, which means if we can find the radius, we'll be in good shape. So we know the volume is pi times the radius squared times the height. And up in calc, we see that the height was given as 15 foot. And the volume was 117.1 cubic foot. So we're just filling in for the volume right here. And what we're going to need to do is solve for the radius. And then we'll be able to find the diameter. So to do this one, we're going to divide both sides by pi and 15 right here. So I got pi and 15. Because that cancels these. And then we got r squared equals. So I'm going to use extra decimals on this just so when we find the answer, it'll be a little bit more accurate. I got 2.4849er.
I got 2.4.
Wait, is that old?
Alright, now to find the actual radius, to put that in my calculator, I actually put that in parentheses, which told the calculator to do this first and then divide. Either way will work. Alright, to find the actual answer now, I will square root both, which will give me just the radius. And since this is a unit of measurement, specifically in foots, then my radius, and I got 1.5764. But this is not the answer because what they really wanted us to find was the diameter.
Oh, then you times up.
So I got to multiply that by 2. So 1.5764 times the 2, bam. And I got the radius equals 3.15.
You mean diameter?
Oh yeah, thank you, the diameter. The diameter is 3.15. That's fine.
Wait, but that's too
Supposed
close
to
to
be
pi.
1.4, and then it's like
so
a
the
perfect circle.
radius.
Yeah. That's interesting, I guess. 11, this has 2 parts, and that's okay. So we got the volume of this cylinder. Let's write this out so that we just know we're going to fill in these spaces. Volume pi r squared times the height. Now this one gave us diameter, once again, the jerks. So to figure this out, as a radius, we're going to divide that by 2. 8.2 is the radius. So I can replace the radius with 8.2.
Oh, wait.
Now this one, we don't have the height, but we do have the volume, which was 4,224.8.
Whoa, don't forget 0.8.
Thank you. Alright, to solve this one then, we can do 8.2 squared times pi first and just see what that gives us. And then we'll just divide by one number. The decimal I got, and we don't need the full decimal, of course, 211.241. Now times h equals 4,224.8. Well, to finish off this, I'll put it on my desk, please. We're going to solve it by dividing both sides by 211.241.
You got another one. That one's for you.
So that those cancel out. Now if I round this, I got 19.9 repeating, which I'm just going to round to be, the height is 20 millimeters. So that's the height, but this next part says find the circumference of the base of the cylinder. Okay, the circumference is the diameter. Circumference is diameter times pi. So the circumference is just its diameter, which was 16.4.
Well, on my paper, it has it written as a C equals pi.
Okay, yeah, so radius times 2 would give us the
Radius
circumference.
squared, sorry.
So, as it turns out, the circumference is just going to be 16.4 times pi. So the circumference would be 51.52-ish millimeters. All right, number 12. For each problem given below, draw and label a picture that describes the cylinder, then solve the problem. That's great. An ice cream company wants to package a pint of ice cream in a circular cylinder that is 4 inches high. A pint is 16 fluid ounces, and 1 fluid ounce is 1.8 cubic inches. What does the radius of the base circle have to be? All right, so on at these. First we should do is figure out the volume in cubic inches. And we got 16 fluid ounces, and each fluid ounce is 1.8 cubic inches. So this will tell us how many cubic inches this is. So 28.8 cubic inches, that's the volume of the cylinder. Yeah, we can draw a picture, and it's very nice. And the radius, they didn't tell us the radius, that's what we need. But we do have the height, which is 4 inches. And this volume needs to be 28.8 cubic inches. So the volume of a cylinder is pi times the radius squared times the height. But we have the height at 4 inches. We don't have the radius, but we do have the volume radical. So we're going to replace the volume with 28.8. So here we go. Find the radius. We'll divide both sides by pi 4. Pi times 4. And on my calculator, I'm going to put that in parentheses. So the 4's and the pi's cancel out. I got r squared then. Alright, 2.292 rounded. So to find the radius, I'm just going to take the square root of both of these. And the radius then is the square root of 2.292. 1.51 in inches. There's our radius. For a science project, Hassan can put a can out to collect rainwater. The can was 11 inches tall and had a diameter of 8 inches. If it rained exactly 20 cubic inches each day, how many days did it take to fill the can? Alright, so let's find the volume of the can. So the volume of this can is going to be pi times the radius squared times the height. Now the radius on this is going to be half of that 8 inches, which is 4, because that's our radius. And it told us the height was 11 inches. So we got the 11 inches radical. So the volume on this one is pi times 4 squared times 11. So 552.9 inches cubed is the volume. But it's only raining 20 cubic inches every day, so to find how many days this will take, I'm going to divide this by 20. And that will tell me how many days. So I'll take that divided by 20. I got 27.6 days. There we go. Now, if you waited the full day, you could say it was 28 days, but you definitely could not say that it was 27 days, because it still would not be filled up. Volume of cones. Recall from 7th grade, not that anyone ever does, that a cone is a three-dimensional figure with a circular base. A curved surface connects the base and the vertex. That doesn't have to make sense, but it should, maybe. The cylinder and cone given below have the same height and their bases are congruent, or the same. But we use the formula 1/3 pi r squared h. So it's important for you guys to remember that the volume of a cylinder is pi r squared times the height. If we turn this into a cone like these, or something like that, then the cone is exactly 1/3 of that cylinder. Now what this means is you could go home and make a cylinder and a cone using the same dimensions and fill the cone 3 times. Take the cone, fill it, and you could fill the cylinder 3 times after dumping the cone into it 3 times. That's better. So we're going to find the volume of each cone described below, and then we're not going to need the drawings for this because we just went over it. All we're going to need is the formula and we're going to find the volumes up in here. So on this one, we got the volume of this cone, which would be pi times the radius squared times the height. But we would divide that by 3. And up in here, we can see that the radius is an 8.4. So that'll be squared. We can put that in parentheses if it helps. And the height is 5.5. So once again, I'm just typing this directly into my calculator. And at the end, that fraction over 3 is divided by 3, which will give me the volume. And that's going to give me 406.4 feet cubed. Done. A cone with diameter 9 meters and a height of 4.2 meters. So on this one, we need the radius instead of the diameter, so we're going to divide that by 2. 9 over 2 is 4.5 meters. Or 9 divided by 2. So our formula, but we have our radius, which is 4.5. And we also have our height, which is 4.2. So once again, I type this directly into my calculator. Bam. And of course, we should not forget the label on this. This would be meters cubed. So we'll find the missing measurement for each cylinder described below. And we'll round our answer to the nearest tenth if it's necessary. In the meantime, however, we'll have these missing values. Here we go, number 3. The volume of a cone is 122.8 cubic inch. So our volume, let's just write out the formula first. Pi r squared times the height over 3. But now we've been given the volume now, which is 122.8. And it says that the height is 4.5 inches. So I'm going to replace the height with 4.5. Now to solve this, because I'm solving for the diameter, which means if I solve for the radius, I'll just multiply it by 2. And then, what I need to do is get rid of that 3. So I'm going to multiply both sides by 3. So 122.8 times 3 as well. So that these 3's cancel out. So I got pi times the radius squared times 4.5 equals... Alright, so 368.4 would be the volume if that was a cylinder instead of a cone. And just like solving for a cylinder, we're going to divide both sides by pi and times that by 4.5. So in my calculator, in parentheses, I'm going to use the pi times 4.5 right here. Now what this does is it cancels these out and leaves me with r squared, which is great, but we'll have one more step. Alright, so 26.06 is the radius squared, but I don't want radius squared, so I'm going to have to square root that garbage, which leaves me with just the radius. And I'll square root these. Square root of 26.06 is 5.10, 5.1. So the radius is about 5.1. But we want the diameter, which is 2 times the radius. So I got 2 times 5.1, which is 10.2. And that would be an inch. Bam, done. The volume of a cone is 188.5 cubic foot. It has diameter 12 foot. Find the height of the cylinder. Okay. So let's use the formula once again. Volume is pi times the radius squared times the height over 3. And again, they've given us the volume, which is 188.5. And this one, they gave us the diameter, so the radius is half of that, which would be 6. So that is 6 squared. And now to find the height, again, we got to get rid of that divide by 3, so multiply both sides by 3. Those cancel. And this will equal pi times 6 squared is 36, just to save us an operation there. And that's times the height. So To find the height, we'll just divide both sides by pi times 36. And pi times 36. So again, this cancels out the pi and 36. Again, in my calculator, I'm going to need parentheses there, so I'm just left with the height. And I am left with 5. I had some decimals, but they were all zeros. 5 foot. Done. Salt and sand mixtures are often used on icy roads. When the mixture is dumped from a truck into the staging area, it forms a cone-shaped mound with a diameter of 10 feet and a height of 6 foot. What is the volume of the salt-sand mixture? Well, once again, we're going to need the formula on this. The volume is pi times the radius squared times the height, all over 3. And on this one, it told us the diameter is 10, so we know the radius then is 5. And it says the height is 6. So we'll replace that with 6. This one I can plug directly into my calculator to get the volume. And I got, and don't forget to label this is in feet cubed. A glass in the shape of a cone has a diameter of 8 centimeters. If the glass has a volume of 200 milliliters, which is 200 cubic centimeters, what is the greatest depth that a liquid can be poured into the glass? So once again, we do want the formula. And it gave us the volume, which was 200 cubic centimeters. So 200 right here. And it gave us the diameter of 8 centimeters. So we're going to cut that in half for the radius, which would be 4. Alright, so once again, we need to get rid of that divide by 3, so multiply both sides by 3, these cancel, and I got 600, and I'm going to square that 4, which is 16, and that'll be multiplied by the height. So, to solve this for the height, I'm going to divide both sides by pi times 16. Again, I would put this into parentheses, because these cancel out, I'm left with just the height. 11.9 centimeters. Done. Recall that a sphere is a set of points in space that are a distance of r away from a point C called the center of the sphere. The cylinder and hemisphere given below have the same radius and height of the cylinder, also the same as the radius. So the volume for a sphere is up there. We're going to write it a little different though. So it's 4 pi times the radius, but that's going to be cubed. And then we're still going to divide it by 3. Now this is for a full sphere. If they ever say it's some kind of hemisphere or half sphere, then we're going to cut this formula in half. Okay. So they are different. We need to pay attention to which one it's saying to do. Find the volume of each sphere described below. If needed, draw and label a picture. We don't need the pictures, but here we go. The volume is 4 times pi times the radius cubed, all over 3. And right here it gave us the radius of 1.3. So I'll fill that in, 1.3. And I can plug this directly into the calculator to find the volume. I've got 9.0. I guess it's 20. 9.2 yards cubed. Not yet. Alright, so we got the diameter is 25 inches, so the radius would be 12.5 inches. So on the formula, the volume is pi, 4 pi rather, times the radius cubed, divided by 3. And the radius radical is 12.5. Alright, so you could find 12.5 cubed first, which is what I'm going to do right here. 1953.125. Alright, so let me plug this into my calculator. So I'm going to multiply that by 4 and pi. And then I'll divide that by 3. And my final volume on this one, pretty big, 81.2. And this is in inches cubed. So on 3, we got to find the diameter on this one. Now again, we need to look at the volume. The volume is 4 times pi times the radius cubed over 3. But on this one, they gave us the volume, which is 6,882.3. So to start this one off, I'm going to have to multiply both sides by 3. So times that by 3. That cancels out, and I got 4 pi times the radius cubed equals, and now I'll divide both sides by 4 pi. Again, you may want to put that in parentheses there. So I'm just left with the r cubed now because these cancel out. I got 1643.03. Now to solve this one, I'm just going to take the cube root of both sides. And that will give me my radius. And it appears I get 11.8 in inches. But this wants the diameter, so I'm going to have to multiply this by 2 still. So the diameter will be 2 times 11.8, which would be 23.6 inches. Alright, so we need to find the radius of the sphere. Alright, so let's write the formula for these. But once again, they've given us the volume, which is 1,436.8 cubic foot. So to solve these, we're going to multiply both sides by 3 first. These cancel. I got 4 pi r cubed still. And now I will divide both sides by 4 pi. Or 4 times pi. Again, in my calculator I need parentheses radicale. So these cancel out and I'm left with r cubed equals. So I have 343.01, but that's r cubed. So I need to cube root both of these. Cube root. And that will give me the radius. 7 feet specifically, and that would give me the radius. Done. Alright, for each problem given below, we may draw the picture, but we'll probably just be using the formulas and solve the problem. If a golf ball has a diameter of 4.3 centimeters and a tennis ball has a diameter of 6.9 centimeters, find the difference between the volumes of the two balls. So the difference is the subtraction. That'll tell us the difference of the two volumes. But we got to find the volume of each one specifically first. All right. Let us start first with the golf ball. Golf. All right, the golf ball. What the heck?
Nice.
That was close. Golf ball. Volume. That's a sphere, by the way, which is 4 pi times the radius cube over 3. But they told us the diameter is 4.3, so cutting that in half would give me a radius of 2.15. Now that means that I can solve this right away for the golf and just plug this into my calculator. Alright, that is the golf ball. Next, we need the tennis ball, which should be bigger. Little tennis. The formula is the same though. Alright, and this one had a diameter of 6.9 centimeters, so cutting that in half would give us the radius of 3.45. So once again, this allows me to put this directly into my calculator. So I get, alright, so the difference between these two is just the subtraction. So I got 172.01, subtract 41.63. And that tells me the difference. And I got 130.38 centimeters cube. That's the difference. Cowrie pours the water out of a cylindrical flower vase, so it's a cylinder, with a height of 5 inches and a radius of 4 inches, into a spherical flower vase. The spherical vase has a radius of 4 inches. Will the water overflow? If so, by how much? If not, how much space are left? Okay. Well, let's start first with the cylindrical. And the volume for the cylinder would be pi r squared times the height, which they gave us both the radius and the height. The radius of the cylindrical was 4, and the height was a 5. So I can plug this directly in my calculator to find the volume. Alright, so there's our volume for the cylinder. Now let's try the sphere. Again, we will need the formula for the sphere. 4 pi r cubed over 3. Alright, well, they did give us the radius on it, these as well. 4 inch. So we're going to replace that with 4. And this is something, again, I can put directly into my calculator to find the volume. So I got 268.08 inches cubed. And that is more. So will it overflow? No, it will not. And how much space is left? Well, let's subtract those. 268.08, subtract the 251.33. So what's left over? 16.75 cubic inch. Bam, I nailed it.